I just finished dropping off another load. Call me crazy for moving in the middle of winter, but I do not like the heat. And yeah, it's 15 degrees outside right now, but we've been very lucky lately. We've had almost no snow in the last month, so no snow, ice, and slush to be slipping and sliding around on. So, most of what I've been bringing over here, well, aside from the test equipment you see up on the shelving, or ledge rather, there is parts. Mostly tubes and other various odds and ends. Big old magnifier there, some CRTs and whatnot. I got a few more loads to go of parts, and I'll start moving over the big stuff. A few of my big TVs and radios, and then, well, all our actual living stuff, our clothes and furniture and whatnot. It's going to take some getting used to not having the high ceilings down here, that's for sure. I do have some some shelving units, some standalone shelving units. So the place I'm at now, the ceilings are over 8 feet high. And in my workshop, I had drilled holes in the wall and mounted shelves on them. Well, here I won't really be able to do that. And the shelving units I've got are all 6 feet tall, and I got just enough clearance here that I can set them up. Won't be able to use a top shelf, but I'll make do. Now, something else I brought over here, some upcoming projects. Unfortunately, those Dumont RA113s, the two chassis I restored, developed problems. They didn't work quite right when the owners installed them, so I had to do alignments on both of them. One of them is working well now, and the other one, I hope is. I just dropped it off today. And then, as soon as I get set up, I will work on a German radio. Once that is done, I think these will be my next projects. Something else that was dropped off ages ago. I promised the owner I would get to them as soon as I could. What they are Motorola VT-71s. You've seen me restore a number of these early electrostatic sets. Well, he refinished the cabinets, but the chassis need some help. So I thought I'd take a little break here and show you what I've got to work with. Before I dig into those boxes, how about a little entertainment? I dug up a power cord for this Admiral 20X122, and I rigged up a simple antenna, just a 3-foot long alligator clip. So let's see what kind of reception I get down here in the basement. And you know, it's actually not that cold down here. If I leave the door open, it's fine even without having a space heater down here. So I think I'll be alright working down here. Man, plenty of sound. Picture's not so hot. There we go. Yes, we still have one over-the-air station left. 21 degrees. Now, something else I got to contend with down here is the poor lighting. I just have 2 bare light bulbs right now. Yeah, I can plug in some lighting into the outlets, but there is a built-in fluorescent unit here that is not working. It's hardwired in, and kind of dubious wiring. I'm thinking the ballast is probably bad, so for now we'll just have to make do with these light bulbs. So I've got a tripod set up right underneath one of them so we can see what's going on. Okay, here is the first one. Looks like we've got all the various bits and odds and ends in these bags, like the knobs and the hardware. And the CRT has been removed. Hopefully it's still good. It's an RCA. Here's the speaker. Got a little bit of a tear, a couple tears, but that can be repaired. And the chassis itself. So at first blush, it looks, well, looks a little different. And this all looks perfectly normal. I've seen plenty of these chassis before, but something odd is going on back here. So normally there'd be a ballast plugged in right here. These sets don't have a power transformer. The tubes are run in two parallel 300 milliamp filament strings with 600 milliamps for the CRT filament. But when you add up all the tube filaments, it's not enough to equal 117. So the ballast comes into play there. And often they're bad, and people make their own power resistors. So I'm thinking this is part of that. But they mounted one on top of the chassis here to dissipate the heat, but there are 3 or 4 elements inside of that ballast. We've only got one power resistor here, so it has me a little bit worried. And somebody wrote down all the tube numbers on top of the chassis as well. Let's see, it's a TS-4J, that's the last revision, January 5th, 1949. So this is one of the last they made of the TS-4 series. Let's see what we got to work with. Oh yes, this has been worked on. Which can be, well, a mixed blessing. Looks like they used decent plastic film high voltage capacitors. Yeah, 8,000 volt Sprague from 1984. I'm guessing it says 8417. So that probably means the 17th week of 1984. Probably alright. But some of this other stuff. So something about that ballast. Well, this is another element from the ballast, I'm guessing. 20 watt resistor mounted underneath. Might be the right value, but underneath, a lot of the heat's going to get trapped underneath here. And actually 6.8K, And it's also, I think, bad because it's rotating. It's a ceramic power resistor, and should not be rotating that freely, so I think then internally the connections are probably broken. Now, as memory serves, inside the ballast there are 2 elements that are about 115 ohms that generate quite a bit of heat, and so there should be 2 power resistors, and we have one down here that's not the right value and one up top, so yeah, it'll require some investigation. And as for these other caps, well, yeah, I don't know. The selenium rectifiers are gone. We've got some silicon rectifiers down here in the terminal strip. That's alright. Looks like some of the original electrolytics are still wired in. Some of the replacement caps, well, they used all kinds of crazy stuff. Got some ceramic caps, some old electrolytics, some plastic film. So, yeah. I'm up to the challenge. I mean, I've got a few spare chassis. I'll get this working, but I'm going to have to really go through this with a fine-tooth comb and compare it to reference photos I've got of other chassis and the schematics and get everything back the way it should be. And hopefully the high voltage coil inside here is still good. Let's see. These are... they were just finger tightened, and there's a bunch of them missing, so I think I can get this off pretty easily. Alright, let's see what we got inside. Alright, looks to be in good original condition. It's an Emerson tube, so I'm knowing that's an original high voltage rectifier. Coil looks to be intact. Alright, so it'll take some work, but I think this one is restorable. Okay, let's check out the other one. Again, everything is taken apart. So here's the picture tube. This is also an RCA. So I hope it's good. Don't know if I brought my Suncor CR70 over yet. If I have, I'll fire it up and test the CRTs. And here's all the hardware, knobs, so on. I can tell these aren't the original. Well, two outer knobs here are the originals, but the channel and fine tuning are not. This is the speaker, yep. Ooh, this has some bigger tears, but again, that can be repaired with a little bit of Eileen's tacky glue. And it's got a decent power cord. The old non-polarized type. And this one looks to be in better condition. At least the copper is nice and clean. It's got a bit of insulation added here. So when this is in the set, the CRT sits about like so, and I'm guessing there might have been an issue with some arcing between the CRT and the high voltage cover here, so that's probably why they added that. Let's see, this is TS-4H. It's an earlier revision, July 22, 22nd, 1948. Shield number 45427. Something's been done to this one. That is for sure. Check that out. It has got a BNC connector and a switch. My guess would be that it is for a direct video feed to bypass the tuner. And here's what the original ballast would look like, which I'm guessing is no good since this just kind of came apart. So yeah, the original ballasts were just some resistance wire on some mica sheets. Might still be okay, even though that came apart like that. But I definitely recommend that they get rebuilt. You can use power resistors, but will generate a lot of heat. Another option, a better option, is to use some AC motor run capacitors or even some diodes. Either one will reduce the power but not generate all the heat. And at least one of the caps has been replaced way back in the day. Sprague capacitor. Alright, well, let's take a peek underneath. Oh yes, work has been done to this, that's for sure. So, it's been recapped, but ages ago. Maybe back in the 50s or 60s. So all these screen caps, they're all replacements, but they're so old, they're probably bad now. These are probably paper caps inside of plastic housing. There might be early type plastic film caps. Do a little research to figure that out for sure. The Cornell Doublier caps. PM6P25 types. PM6P5. $6,000 caps. They used one ceramic cap for whatever reason. And then these guys say they're high voltage caps. Tube shield fell off. And as for that switch, well, here it is, and there's really nothing connected to it. Just one lug, and that's going to a cap. And here's where that BNC's coming in. And it's going to this cap, and this 100 ohm resistor going to another cap, going to the common lead. I don't see any other connection to it. So may have been an experiment that didn't pan out or was never finished. Well, like the other chassis, what I endeavored to do is to put this back stock, matching reference photos and the original schematics. So I've done both TS-4H and TS-4J chassis before, and I have tons of reference photos, and I have a couple spare chassis. So again, I think I can get this guy working too. This has all the screws still on the high voltage box. I don't have a 1/4 inch wrench handy, so I'm not going to take this off right now. Oh, what fell off was not a tube shield, it was one of the covers and capacitors. Notice how these caps, it's black around here, and they have cardboard covers on them. Well, that's because it's not exactly a hot chassis set. Yeah, no power transformer, but the chassis is not connected to either side of the AC line. It's kind of floating. But these caps, the outer metal surface is connected to a high potential. Well, these do go to one side of the AC line, I guess you could say. So that's why they have a cardboard shield over them. You would not want to touch those and get zapped. And this fell off again. So I will have some fun on these. It's always nicer, I should say, to work on sets that nobody else has ever worked on, or has been minimal repairs done way back in the day. Because when you work on sets that have been tinkered with a lot, you have no idea what somebody did to them. I'm up to the challenge. It'll be interesting. I've worked on a bunch of these, and the ones I've worked on so far have been pretty much unmolested, so it'll be interesting to try to unravel what somebody has done to these and get them working again. That for sure is a puzzle. It says ham next to the switch, which I actually think ham radio operator, of course, but with basically this switch and this connector not really going to anything, I don't know what they were trying to do. Yes, I do indeed have my trusty Suncor CR70 here. I got it set up to test the 7JP4, and I hooked up the universal adapter. Now, unfortunately, some of these pins are damaged, which is a very common issue with these 7JP4s. It's still attached to the elements inside the CRT, but it broke away from the big light base. I've seen this problem a few times before. A little dab of super glue is a quick fix to hold it in place. If they're really bad, it may warrant replacing the entire base. Now this one's on solidly, so I really don't think that I would need to go that far. Alright, well, let's see if it's any good. Now with the shield in place, it's hard to see if the filament's glowing, but experience tells me if the filament's open, when I'm in the filament set mode, the needle would be much higher. So when I'm in this mode, the numbers across the top mean the filament voltage. So I want to adjust the filament set to get it on 6.3 volts. And I can kind of tell as I turn this filament set up, it's kind of dragging the tester down. So I'm pretty confident that there is a load on the filament there. Let's go to the HK shorts, G1 shorts. Now if this electron gun was not working at all, this needle would be well into the bad, so I'm pretty confident we are emitting some electrons. I'll go to the cutoff. It's jumping around a little bit there. Probably a loose connection. Alright, things have stabilized. Now when I rotate this control, the needle moves like it should. Get it inside the black box. On the meter there for the cutoff set. Go to emissions. And I've got solid emissions. Now I've tested a bunch of 7JP4s and pretty much they all have good emissions. That doesn't mean you're going to get a good picture. You really need to connect these to a working set to get a true indication of how well it's working. But when they are working well, you get a glow on the face of the CRT while you're testing it. So it's normally run on 6,000 volts. This tester only puts out a few hundred. So if you get a spot on the CRT face, that's a really good indication you've got a pretty healthy CRT. I can also do the life test. Make sure I get the cutoff in the right zone there. Now I've only been running this thing like a minute or so. I should really let this run for a while. And I think because of those bad pins, I got some connections that aren't that solid. But let's see what the life test tells us. The life test, rock solid. So I think if I repair those base pins, we've got a pretty healthy CRT. I'm not crazy about the way it's jumping around. Well, I'll touch up the pins on the base here with a little solder and get these secured, and hopefully this will be a good CRT. Now let's try the other one. Alright, here's the other 7JP4. All the base pins are very solid on this one, and we can get a better peek inside the electron gun. The shield's a little bit further up on this one, so hopefully we will see a glow this time around. And again, there seems to be a decent load on the tester. I adjust the filament voltage. Yeah, you can see a little bit of a glow down in there. Hard to see, but I'm seeing a little bit of light down in there. Yeah, there we go. Alright, so no HK shorts, no G1 shorts, cutoff controls, kind of erratic. Again, when this pitch tube hasn't been running like 50 years or however long it's been, best to let it sit for a while. But let's just jump right to emissions and see if we get something. Oh yeah, wow, it's way higher than the other one. And this one also has a glow, even brighter. So, just doing this quick impromptu test, I would say that this CRT is even healthier than the other one. Again, it should be connected to a functioning set to know for sure. Life test on this one, also rock solid. Alright, so it'll be interesting once these sets are working to see what the difference is. This topic comes up all the time on the forums of how to test a 7JP4, and again you see, yeah, this will give you an idea if it's dead or not, or if there's any shorts or not, but you really got to put it in a working set. So my money is that they will both work, and this one will work a little bit better. Let's see if that holds true. It'll be a while before I get to these, but at least I've got some idea what I've got to work with now. Huh, go figure, as messed up as this fluorescent lighting fixture is, I fiddled around with it and got it to actually work. Still want to replace it someday, but for now, at least I've got more light down here.